Hello everyone, welcome to all of you in Chemistry by Sadhanwar, and this is my WhatsApp number. I am your science and chemistry coach. I have been providing my tutoring and educational services across the globe. You can contact me as well, and this is my lesson number 4. I have uploaded 3 lessons about this topic and about this chapter, and the name of chapter is speed of reaction and the rate of reaction. Now let's discuss another new topic, and that topic is about collision theory. So guys, this is about collision theory. Now we discuss what actually collision theory is and what is the story of collision theory. Guys, remember, when a reaction is taking place, reactant molecules come close together and reactants molecule collide with each other. And when reactants molecule collide with each other, then reactant molecule will be able to convert into product. And if there is no collision between reactant molecule, then this is not possible for reactant molecule to transform into product. So when reactant molecule wants to when we want to convert reactant molecule into product, then collision is necessary, collision is essential. And the one important thing is that the collision should be fruitful. So we can say that what is fruitful collision actually? Fruitful collision, fruitful collision. Let me write first. Oh, what happened, guys? 1 second. So fruitful collision. Fruitful collision means that collision in which reactant molecule gets enough energy to convert into product. Otherwise, reactant molecule collide, but they bounce back. Reactant molecule will collide with each other, but product will not form, and reactant molecule just bounce back. So what fruitful collision is? Fruitful collision is when reactant molecule collide, they collide in such a manner that reactant molecule will transform into product. This is fruitful collision. Otherwise, reactant molecule just collide and they bounce back. So this is the concept of, we can say this is the concept of collision theory. Now let me erase this. Okay. So guys, this is magnesium, and when magnesium react with HCl, this product is gonna form here. The important point of collision theory is particle must collide with each other, and collision must have enough energy to be successful. Fruitful collision, successful collision, fruitful collision. In other words, enough energy to break bonds to allow reaction to occur. So what actually reaction is? Reaction is a bond will break between reactants and a new bond will form among products. So to break the bond of reactant molecules, enough energy is needed, and this is provided by, we can say this is provided by collision. Collision must have enough energy to be successful, to be fruitful. In other words, enough energy should be there to break bond, to allow a reaction to occur. Otherwise, no reaction. Let's take this diagram. This diagram will help us to understand these things. 1 second, guys. Okay, now let's start. This is acid particle, this is water molecule here, and this is magnesium atom. There are reaction between magnesium, which is solid, and acid, which is HCl, and acid is mixed with water, aqueous, and this is the product here. The particles in the liquid move non-stop. To react, an acid particle must collide with magnesium atom. So acid particle, these are 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 acid particle. Acid particle must collide with magnesium atom and bond must be break. Then reaction will be possible. So you can see reaction is taking place here. The collision has enough energy to break bond, so it is a fruitful collision, so it is a successful collision. The particles react and a new bond form, giving magnesium chloride and hydrogen. We know when magnesium react with hydrogen, the product is magnesium chloride and hydrogen gas. To make this equation balanced, let me put 2 here. Remember guys, if collision is not successful, then molecules or particles atom just bounce back and no magnesium chloride will form, no hydrogen gas will form. But this collision did not have enough energy. It is not a successful collision. It is not a fruitful collision at all. It was not successful. No bonds were broken. The acid particle just bounced away again. Hope you are getting me. You can ask question, guys. So we can say that if there is more successful collision, then rate of reaction will increase. If there is less successful collision, then rate of reaction will decrease. So we can say that rate of reaction depends on how many successful collision there are in a given unit of time. So changing the rate of reaction, how rate of reaction will change when rate of collision will change. Why rate increase with concentration? This can be asked as a question. Why rate of reaction will increase with increasing concentration? If the because if we increase the concentration, then there are more particles and there are more molecules. And if there are more particles in a given area, in a given space, and if there are more particles, more molecules in a given space, then rate of collision will increase. If the concentration of the acid increases, the reaction goes faster. It is easy to see why. Why? So let's see why. Let's see answer of this why. Why? This is acid particle, this is water molecule, this is magnesium atom. You can see here we have just 4 acid particles, but here in this picture, in this diagram, we have so many acid particles. So concentration of acid is increased here. More acid here, and less acid here, less acid here. And this is a dilute acid, because dilute acid means less acid particles and more water. And this is concentrated. Concentrated acid means more acid particle as well. So there are less chances of an acid particles hitting, colliding with the magnesium atom. But here in case of more acid, this is concentrated acid. Means concentration of an acid is high. Concentrated acid, concentrated acid. What does this mean? This means concentration of acid is high. There are more acid particles, so there is now more chances of a successful collision. The more successful collision there are, the faster the reaction. Move on. The idea helps to explain why the reaction between magnesium and hydrochloric acid slow down over time. You see here we have more magnesium atom, here we have less magnesium atoms. When we have less magnesium atom, when we have less acid particles, it means rate of reaction will slow and eventually finally reaction will stop. So if the question is explain why the reaction between magnesium and hydrochloric acid slows down over time, the reason is because the reactant magnesium atom and the other reactant acid particles has been consumed now, has been used now, and their concentration is low. The concentration is very much low, and the collision among reactant particles is now very little, very fewer collision, very less collision. So the reaction slows down over time. At the start, there are plenty of magnesium atoms and acid particles, but they get used up in a successful collision. After a time, after a certain specific time, there are fewer, less number of magnesium atoms, and the acid is less concentrated now. So there is less chances of successful collision, so the rate of reaction will be decreasing now. You see, when magnesium react with HCl, the product gonna form is magnesium chloride and hydrogen gas. So there is a graph of a volume of hydrogen gas at y-axis and at time. Now see, in the beginning reaction is fast. A time will come then this curve is flat now. Guys, you know, when there is a flat curve, what does this means? Game is over. Reaction is stopped now. As a result, slope of the reaction curve decreases with time as shown above. It goes flat when the reaction is over. Game is finished now. So the other factor is why rate increase with temperature, because we know when the temperature is increased, the rate of successful collision also increase. Because why? When we increase the rate, the energy of the particles is directly proportional to the temperature. When increase the temperature, actually, when we increase the temperature, the energy of the particles is directly associated, directly linked with temperature. So when we increase the temperature, what happened, guys? Energy of the particles increase, energy increase, the velocity of the particles increase, and the collision rate increase. And when collision rate increase, you guys know that rate of reaction increase. So the point is, why a rate increase with temperature? On heating, all the particles taking heat energy. Like you see, acid particles, water, magnesium atoms. This makes acid particles move faster. Why move faster? Because increasing temperature means more heat energy. More heat energy means, like, if we increase the temperature, it means more. If we increase the temperature, it means more heat energy. More heat energy. What does this mean? This means more collision. More collision. What does this mean? This means the reaction, rate of reaction, speed of reaction is increasing now. The extra energy also means that more collision are successful, so the reaction rate increase. You see, this is the reaction at normal temperature, and the curve of this reaction goes like this. But when we increase the temperature, the curve goes with more steep curve, the more steepest curve. More steepest curve means the rate of reaction is increasing. The more fastest reaction. The final volume remains same. The final volume remains same. If you feel anything difficult, anything confusing in my lecture, don't hesitate to ask question. Do ask question. But what is going in your brain, what is going in your mind, don't hesitate to ask. Do ask question. What is happening? Oh, good. So why rate increase with surface area? We discussed this process as well. When we use more surface, when we increase the surface area, collision also increase. The reaction between the magnesium and acid is much faster when the metal is powdered. When the magnesium is powdered, in the powdered metal, many atoms are exposed, so the chances of collision increase. While here you see these atoms, they are not exposed to collision. Here almost all the metal atoms, all the magnesium atoms are exposed to collision, and when there is more collision, the rate of reaction increase. So I think these things are clear to you now, clear to you guys. And later on, this is my next topic, and I will upload the next video about this topic. In this, I will briefly discuss what catalyst is and how catalyst enhance the rate of reaction. How does catalyst work? I will discuss this topic later on. I need your feedback, comment. I need your suggestion. Guys, do share this video with your classmates, with your class fellows. And thank you so much for watching. Okay, goodbye.